These are our area of a trapezoid notes. So, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So again, parallel means lines that will never intersect. So they shouldn't be touching. They're two lines that travel same distance apart from each other the entire time. A trapezoid is different than the other shapes we've talked about because a trapezoid actually has two bases. And these two bases are those parallel sides. So those lines that are traveling side by side and never touch. The height will still form a 90-degree angle with those bases. So your height still is making that perpendicular intersection. So you're always looking for that little perfect corner. So just like with the triangle and the parallelogram, we are only using the straight edges. So if there's numbers on the slanted lines, we don't want those. We only want numbers that go with straight lines. Down here, it says to label the bases and the height. So we're going to highlight them. My bases are blue. So my bases are straight lines that are parallel. So in our first example, I don't need to zoom in, the bases are the top and the bottom line. Because they are straight, they are never intersecting, and they are parallel. In the second trapezoid, our bases are actually the sides because they are two straight lines that will never meet. And in our third trapezoid, the parallel lines are the measurements of 12 and 15. So those are our bases. I'm going to come back and label those with the letter B for base. Okay. The other part we need to find the area is the height. So the height has to make a perpendicular angle. So we're always looking for those straight lines. So that's the red dotted line in the first one. It's this bottom line in the second trapezoid. And it's that measurement of 6 centimeters in the third trapezoid. Again, we're going to label them with an H. And then your reminder, you are still looking for those perfect corners. So trapezoid 1 and 2 drew the perfect corner for you. Trapezoid 3 did not, but the only other number here is this 7 on the side, and that's with a slanted line. And we're not using those. We're still only using straight lines. The area of a trapezoid's formula is a little different. You also have to remember to apply PEMDAS when solving area of trapezoids. So you have base 1 plus base 2 times the height divided by 2. So extra base means extra steps. The most important part when you're finding the area of your trapezoid is you have to have both bases and the height in order to find the area. So you got to identify those lines first and ignore the extra numbers. We have 4 practice questions down here. So I'm going to start by writing the formula so I know what I'm looking for. Our formula is base plus base times height divided by 2. So in trapezoid 1 right here, we're looking for the parallel lines, and those make up our bases. So you have this 4 and 6 as 2 straight lines that will never cross. So these are the bases that we need. The height is the straight line that separates the bases. That makes that perfect 90-degree perpendicular angle. So that's actually going to be that 3 over here. And again, we are not using the 5 because it's on a slanted line. So here we go with all of our math. So this is going to be 4 plus 6, because those are the 2 bases, times our height of 3, divided by 2. PEMDAS, we do our parentheses first. So 4 plus 6 is 10. 10 times 3 is 15. Oh my gosh, 10 times 3 is not 15. 10 times 3 is 30 divided by 2. So the answer is 15 feet squared. Kind of gave y'all a spoiler on that one. Okay, number 2, same thing. We have a trapezoid. So we're going to start by writing our formula. Base plus base times height divided by 2. Again, our bases are the straight parallel lines. So in this example, it's going to be the 4 on top and the 2 on bottom because those are straight lines that will never intersect. The height is the straight line that separates them. So that's going to be this 3 because there's your perfect right angle. So there's our height, base, and base. So now we're going to plug in the numbers and solve. So we have 4 plus 2 for our bases times our height of 3 and all divided by 2 at the end. So using PEMDAS, 4 plus 2 is 6. 6 times 3 is 18. 18 divided by 2 means our area is 9 feet squared. And again, your units are still squared because we're still finding area, that space inside the 2D shapes. Okay, trapezoid number 3, same thing, same formula. Base plus base times the height divided by 2. Your bases are parallel lines that never touch. So 5 and 9 are our straight parallel lines that never touch. Your height is the straight line that separates them. So in this example, it is that 3. So now we're going to plug in and solve. 9 plus 5 times 3 divided by 2. 9 plus 5 is 14 times 3 divided by 2. 14 times 3 is 42. 42 divided by 2 means the area of this trapezoid is 21 centimeters squared. And our last trapezoid, still using the same formula, base plus base times height divided by 2. This one gives us extra numbers. So my first question is, do we use the numbers on slanted lines? The answer is no. So this is a slanted number and this is a slanted number. We don't need those. So I'm going to go ahead and cross them out. They're extra information. Your bases are the 2 lines that are parallel. So in this example, that is 11 and 13. And then our height is the straight line or the perpendicular line that separates them. So that's the 4. So we have 11 plus 13 times 4 divided by 2. 11 plus 13 is 24 times 4 divided by 2. 24 times 4 is 96. 96 divided by 2 means the area is 48 inches squared. Now, the only thing is, with all of the practice here, the base was always the top and bottom numbers. That is not always the case. So just remember, your base has to be the parallel lines. So kind of like up here where we highlighted, in this example, your bases can be the sides as long as they are parallel.